Hello everyone, and welcome to part 2 now of the 4.4 notes, where we're continuing to examine some of these logarithmic expressions, the different ways that we can use properties to simplify these. In some case simplify, in some case it might not look like we're simplifying it, we're kind of expanding it or doing these kinds of things. And so that's actually what we're going to try right now. We're going to use these product property, which, if you can remember, the product property and the quotient property, they're very closely related. But sometimes we have to use both of them in the same problem. We'll see something like this where actually both the product and the quotient property are coming into play. For example, in number 10, we have the log base 3 of 5z divided by w. And so notice this 5z over here, I'm going to put parentheses around it because this whole thing is in the numerator, and that's what's being divided by w. And so when we use the quotient property to expand this one, we should go log base 3. Of course, always the base stays the same. We go log base 3 of the numerator, which is 5z, and then it goes minus log base 3 of the denominator, which is w. But now inside of this, what used to be the numerator, we have a product over here, this 5z, and so we're able to expand that one as well by using product property, and we can go with the same base, log base 3 of 5 plus log base 3 of z minus log base 3 of w. And that will be the fully expanded form for this one. And now we will try this one for number 11, but we should pay attention to what's going on in this one. We actually have a product in the numerator and the denominator. So this AC, that's the numerator, is going a times c, and then in the denominator we have 5d, so it's going 5 times d. Now when we do the first expansion, by expanding, to me it seems natural we would expand on the divided. And so we will use the quotient property for this one. We should go log base 7 of the numerator, which goes AC, minus log base 7 of the denominator, that goes 5b. And then whenever we're going to use the product property to expand these, we must be very careful of this minus sign that is here. Always when you have this minus, you should think to yourself, am I doing something that should require me to distribute this minus sign to something? And of course it is. You know, we're doing minus this log base 7 of 5d, so whenever we expand this one into a product, really we're subtracting the expanded form as well. And so I just want to put the bracket to keep this minus sign there, and so we can be mindful of that one. And so the first term we will expand on the times right here, so it will go log base 7 of a plus log base 7 of c. And then it will go minus this thing that goes log base 7 of 5 plus log base 7 of d. And so we're getting close to the expanded form. We should probably just distribute the minus that's there. And so it will go equals log base 7 of a plus log base 7 of c, and then minus both of these, log base 7 of 5 and minus log base 7 of d. And so there's a chance to make a mistake over here, maybe by having plus here instead of minus. But if you're very careful of the minus, then you don't have to worry about it. And then we can see, why don't we see one of these very nice ones like number 15. We will have such a nice expanded form for this one. And we'll be able to simplify a little bit as well if you can look ahead. And so what we're going to have here is a numerator and a denominator. So we will use the quotient property. It will go log base 8 of this numerator, that goes 64x squared y, and then it will go minus log base 8 of this denominator, that goes 3z w cubed, like this one. And so now we have these products. We can expand by product rule, so it's going to go log base 8, and this equals is going up to that one. It goes log base 8 of 64 plus log base 8 of x squared plus this one log base 8 of y. And then it's going to be minus a bunch of stuff because we need to expand this, but being careful again for the minus. So it will go minus this thing, that will go log base 8 of 3 plus log base 8 of z, and then plus log base 8 of w cubed. And writing this log base 8, you know, it's so much writing to do. That's why in the future we will prefer ln over any of these other logs. If we have to apply log, we can choose ln every time because it's so much easier to write. There's so many less pin strokes to write ln than it is to write log base something. But anyways, we will in one step distribute the minus, but then we should also here handle these exponents. You notice this 2 on the x, it can go into the front. This second power here can go into the front. Also, we have this 3 right here on the w, it can go into the front of this one. And we're able to evaluate this one actually to get a number for this log base 8 of 64, because that one's like log base 8 of 64 can be written as 8 squared. So we could think of this as putting the 2 into the front, and then log base 8 of 8 is 1. So this whole thing will just be equal to 2. And so we will have 2, and then plus 2 log base 8 of x. And then we have also plus log base 8 of y, minus log base 8 of 3. Also another minus here, we're distributing log base 8 of z. And then minus this 3 comes into the front, so minus 3 log base 8 of w. And that will be the final result for this one. And now we're able to use these properties, of course, not only to expand the one, but in some cases we want to make a contraction, as it were, to write something like this. Here, for example, we have a difference of logs. But you notice this would be the result of using the quotient property to expand before if we had divided. And so that property, it works both ways. Where here we're able to write this one instead of it being a log. And by the way, these bases are the same. They're both log, so they're both log base 10. We have to have the same base, of course, in order to use these properties. But we have here log of something minus log of something, so we can write it as log of the first term, the 4x minus 3, divided by the other thing divided by x, like this one, log of this. So we would write it this way. And then there are some very interesting ones here. Why don't we take a look as well at number 19. This one looks very fun to do. We have here these brackets, and we can handle what's inside of here, and then we will look at what else there is to deal with. And so it goes 2 times of this thing, ln of x minus ln of x squared. So we can write that as 2 times. We put the first argument divided by the other one, so it will go ln of x divided by x squared. And then we're picking up here, it goes plus 2/3 of this. Notice here, though, we're able to use a nice property. We can put this coefficient back into the power here, and so we should multiply that power by 2/3. And so it will go here plus ln of z to the 9 times 2/3. And of course here, if it's a little bit tricky of thinking about how we should do it, it's really because we're putting this power of 2/3 onto the whole entire argument. So the argument of z to the 9th power, we should put 2/3 as an exponent on there, but then of course the exponent rule says that we should multiply these exponents. And so that's what we will do in the next step. But then it goes minus ln of z. And so we're not in a hurry to do this in one step or something like that. We will take as many steps as possible. Now here, we have x on the top, x squared in bottom, so we're able to cancel one of these x's. And it would just leave ln of 1 over x. And so we can write that one. It will go ln of 1 over x. And then it goes plus, in this case, ln of here, we will multiply the exponents, and so it will go ln of z 9 times 2/3. You can think of the 9 and the 3 cancel, leaves 3 here, so it becomes 6. And then we'll go minus ln of z. And now here I want to use this 2 also as the power onto this argument. It's going onto the whole thing of 1 over x. So it will go ln of 1 over x, and then this thing is squared, which if we put the square over here, it means that we should go squared like this. It squares both of them, but I will write it this way. And then it will go plus. Here, since they're both z, it seems very nice at this point to do the quotient property for these. And so it will go ln of z to the 6th divided by z. And we're able also to do a cancellation where the z on bottom and this z on top will cancel, leaves 5 of them. And so now we're able, at the very end, to write this one using one more rule. We will use the product property for this one. Since it's ln of something plus ln of something, we can write this one like ln of 1 over x squared times this thing z to the 5th. And it's very natural as well to put the z to the 5th just into the top. So we'll go ln of z to the 5th divided by x squared. And that will be the final result for this one. And so that does it for how we will do these kinds of expansions, and also taking the expanded form, writing it as a single logarithm, for example. There is one last little thing to look at for the properties of logs, which is called change of base formula, and we will see that one in the next video. So thank you guys for watching, and I'll catch you in the next one.